Right. Hello. So, quick status first. So, yeah, after two, it's such a ironic. Like after two throat infections on Monday, we were at the doctor's with our youngest. Clears, everything's top notch. We're done with it. It's been exhausting, and then we come home, and he gets a fever, and now he has the flu. So we're still home. My partner seems to have the same thing, going to the doctor today. Like it's just never ending. But at least now it's like normal sick. It's not the worrying how like if he doesn't take his medicine, things can go bad kind of thing. So that's good. But in between all of this, I'm not sure where it comes from. If it's because I've been feeling isolated, I kind of escape through ideas in my mind, or it's just a coincidence. But I've been playing around with this idea where basically the thing I've always been iterating on is the frustration with React and state management, and then trying other solutions like Vue and Solid, and not feeling like I feel like I'm losing what's good about React, which is the reconciliation of UI. That's amazing. But that reconciliation with state management is what makes state management horrible in React. And then it's like, okay, what would it look like to combine the two things? And I've gone through so many iterations. It would be fun to look at, kind of like create a summary of everything, because it's been like different abstractions for React, like even this impact, this project, which never really came to anything. We tried to see if we can make Vue work. And then the thing that kind of need to be distilled was kind of the interface, like how, or the signature, like how should it look like if you want to combine state management with reconciling UI. And the cleanest way to do that, which I really like, we've done this before, like in the Vue experiment, we did this, but it wasn't obvious to me until I saw Remix 3 being introduced, and they have the same signature. Like it's a very different experience, but the signature is the same. It's having a function that returns a function, so that you think about the component as a setup. Like this is where you do your state management. The function is called once, and then you return a reconciling function. So this function will be called again and again whenever the state it accesses or the props it's accessing changes. And that makes a shit ton of sense to me. And everything's kind of like coming together, because when React was moving away from classes into functions, like they first took a step into pure functions, right? There was no hooks, nothing. And then they had to decide, are we going to have class components for state and pure functions, which I think could be a good like end result. But they wanted to leave classes behind and then embrace functions. And there were two things they could do there. Like they could do what they did now, which is like, okay, let's introduce state management and everything inside the reconciler, so that you still just have this one function, but it's not really pure anymore. Or they could have chosen something like this, where you didn't have like pure functions in the same sense. You would rather return a function from the component. But then it's kind of weird, right? You have, what if you do want a pure function? You kind of have to create a function that just returns a function, which can feel weird, right? And that's something I'm still like reflecting on here. is like, how could you still have pure functions that's just returning some UI but doesn't have any state management, but you can still define a function that returns a function, and then you get state management. So basically, if you do like create state and you don't return a function, then it's like it's incompatible, right? Anyways, and then I went through a ton of iterations on like how to build this thing. So first I was using Snabbdom, and that kind of worked, but I had big challenges implementing things like context, and it wasn't really built for what I needed. And then I tried to build my own vDOM library. I got it working, but it was like super slow compared to other things. And then Adam mentioned Inferno. Like, I know Inferno very well from before, but I had no idea it was so low level. So I replaced it with Inferno, and Inferno has everything we need. So the implementation is super, super simple and smooth, and everything just kind of works. So that's, I think this is worth like at least publishing as a thing, because it makes a statement. Like just reading this first part, like why is there mental strain with React and why is there mental strain with Solid? It's because they're trying to merge state and UI expression into one mechanism, it being observability or it being reconciliation. While I personally think they should be expressed in two different ways. So state management needs an observable mechanism, because then there's no crazy functions being called again and again with still closures and all of this shit that you have to deal with in React. And then the UI expression needs to be a reconciler, so you can just use the language, if statements, for loops, maps, whatever, and you don't have to use these magical components and compilers, and kind of have to get past the fact that it looks like you're returning a static UI. Like here, you're literally returning a static UI. You're returning 0 here, the number 0. But under the hood, the compiler will change this count call into not an eager call. So it will just reference count, and then like as the element is evaluated, the child will be called and observed and all of this stuff, like the count text child. Anyways, so yeah, this makes a lot of sense. What I mean to say, that message in and of itself is worth like publishing this, because the biggest problem here is like ecosystem. Like, that's the great thing about Tailwind, right? You get all these components and everything kind of for free, and since it's Inferno, you can easily use React code examples, and it will kind of just work with Tailwind. But then you have like actual React libraries that really won't work with this. So, but yeah. Anyways, so what I thought we could do is, let's see. I thought we could just implement something. So one thing I want to do first, I want to make an optimization, see if I can make that work. Close all. Let's see. So the way this works, it's actually very simple. So we have this JSX runtime, which like Inferno and React also has. But what we're doing is, instead of like using Inferno's JSX runtime, we use our own. But then we implement what the Inferno JSX runtime has. So you can see here, if it's type of string, we create an element, and if it's type of arrow boundary. So yeah, and that's also the really nice thing, is that Inferno has this legacy, like what's called the legacy context in React, which allows us to, like, Inferno is an implementation detail here. So you don't think about Inferno at all, but we can use those mechanisms to implement things like error boundary, which is super, super nice. Yes. So there is some overhead to this, like run the benchmarks. I think we have them here. Let's see. I think I have it. Let's see. Been discussing with yeah. So if we look at JS benchmark framework benchmarks, oh, I guess this is it, right? Yeah. So if we look at Inferno, wait, Inferno, here we are. So this is Inferno, and then we have, let's see, let me download. Open in preview. There we go. Sorry. Here we go. So we have Inferno here, and let me make this a little bit smaller. Okay, cool. So we can see that it's a little bit slower, but these are like, is this like micro seconds or something? And partial update, select row. And these are like really weird examples. Like you have 1,000 rows. And then swap rows. So you see it's like consistently a little bit slower. But that's perfectly fine because Inferno is crazy fast. So if we look at React, where's React? I think it's called React hooks. There we go. So if we compare it with React hooks, you can see it's pretty much on par. I'm wondering what, so the nice thing is that, so one thing, the biggest overhead we have is that every single component becomes a class component. And this is why I'm still reflecting on like, how could you still have functional components and then only have class components where you actually need to do state management? Because these benchmarks are like optimized, even for Inferno. Like they're highly optimized for like the way they're written. React uses memo, for example. The problem is that in a real app, you don't actually use memo all the time. That's why React is slow. It's just too complex, the dependency, what's it called? Not diagram, but dependency map. Like you can't reason about it in your head. But then you see things like swap rows is like crazy much faster. Create many rows is quite fast. Clear rows, but again, like React is also really fast. That's the thing. Like React is fast in isolation. The problem with React is when you build an actual application, because you have to do so many things to maintain the isolation of updates, right? And the point is to create something where you don't have to think about that, which you don't have to think about in solutions like Solid or Vue or any of the others, but you have to think about it in React. And then you're getting the React compiler. that changes this. You don't have to think about it. And that's a good thing. But still, you have to have a compiler. And you still have all the mental overhead of like the reconciler with state management and all of this stuff. So yeah, but those are like some numbers. So the point is really, it's like you're looking for a developer experience. Where's the thing? Yeah, you're looking for a developer experience. And performance is like what do you call it? You have hygiene factors and motivation factors. I think that's what you call them. Anyway, so vDOM performance is like a hygiene factor. It just needs to be performant enough. It's not like the more performant it is, the better the developer experience becomes, right? It just have to be performant enough. But then the actual developer experience comes from the public interface that you actually interact with as a developer. So here you have, well, it's straightforward. As I said, you have a component, you return the UI, you're free to do if statements, whatever. And you have like what you would expect, like on mount, create state. You can use this like, what do we call it? The constructor pattern or whatever. I can't remember what we called it. So you can like move functions behind, or not behind, but after the return statement, if you want to do that, to keep things like very consistent, which is super nice. Everything's a reactive object. So props, state, context. We're gonna implement computed here. And async, queries, mutations, everything's like a reactive proxy. So that's also a nice thing here, is that you don't have different variations of how to consume observable values. Like, I'm not saying it's like a super bad thing, but in Solid, as an example, you have two variations. Some values needs to be called as a function, but if you create a store, it's a reactive object, so you don't have to call a function. It's just inconsistent. Well, I think it's better to just double down on one way of doing it. You have reactive objects. So if you want reactivity, it has to be an object. So that's why state needs to be an object. Props is already an object, but also computed needs to be an object of computed properties. Even if you just have one computed, it's still an object. It's just for consistency. But the thing you have to accept though, is that when we choose this signature, or this like reactive object approach, you can't destructure them. If you do that, you're gonna break reactivity. So that's like the one rule of thumb, is that props, state, computed, context, given it depends on what you're exposing on the context, of course. But if you're exposing a reactive object on the context, when you consume that context, you shouldn't destructure it. The async, the query, the mutation, just don't destructure it. And the good thing about that, first of all, is like consistent, because you think about these as reactive objects. And they don't have different signatures. It's just an object. But another thing is that you're kind of forced into this pattern where you actually always have the source and then the value. So you always see where the count came from. It came from state. Or if count came from props, or name in this example, you know that it comes from props. So that's kind of a nice side effect of that. I think it becomes more readable. But again, it's incredibly unexpected if you happen to, like, I'm in my muscle memory, I destructure props all the time. So even just testing this, I've been like destructuring props, and then it like, you get the initial value, but then the reactivity doesn't work. And it's like, why the fuck isn't this updating? But it's like with everything. But that mental strain is so much lower than anything else. And you can have like linting rules, for example, that handles this. But yeah, so you have render, you have create state. We have something called create view, which is another thing about reactive objects is that you can't spread them. So if you want to create like counter in this case, which is like state with certain functions, you would expect to like return like an object and you spread the state and then you add increment, decrement and reset to that object. That doesn't work because it's literally destructuring the state in this case. Spreading is destructuring. So to alleviate that, there's a create view where you can take any plain old object or any reactive object and it will merge them together so you keep the reactivity. But this is how you compose. It's just like hooks, but instead of like use counter, you say create counter because you only create it once, right? And then you just put everything you need in there as normal. And then you would typically return like create view. And you can pass this on a context. Ref is the same. On mount, on cleanup, as you would expect. The cool thing is though, since you have a setup phase, you can just add like an interval there and then clear it on cleanup. You don't have to. This is maybe the biggest mental strain is like instantiating things, like a timeout in React. You have to use an effect for that. You can't just like do it. There's no such thing as this is. There's no constructor in a component in React, which makes it hard to reason about. And then context API is pretty nice. You create a context, and then in any component you can inject the value. I call it inject instead of set because you're literally injecting the value in that component. So nested components consume that value. Because you can inject different values in different parts of the component tree. But anyways, and then you just get the value. So everything's typed and nice. And then you have these async things like if you just need a promise, you'll get like a reactive version of that. And here you see like why it's so nice to have a reconciling UI. Oh, look at that. It's still wrong way. You can just say if user is pending, return this thing. If user error, return this thing. Or return this thing. And this is like type narrowed, super readable. You don't have to have like multiple show components without the type narrowing, and so on and so on. And then you have create query, which is like just an abstraction over create async, where you have a callback instead, so you can like refetch and it handles what if it's already fetching. It's going to ignore the old fetch and then prioritize the new fetch. You can fetch in the background, so it's set to is pending, but you still have data there, or you can force fetch, which is going to nullify the data and put it into is pending. And then you have create mutation, which is basically the same. You just have this reactive object that tells you if the mutation is pending, what params you pass on that mutation, so you can show optimistic updates, if an error happened, all of that stuff. And then error boundary, blah, blah, blah. Yeah, we're gonna fix this. And then as I mentioned, composition. Yeah, so it's super nice. And Inferno has like portal. I'm not exposing that right now, but it has it. And it's really nice to not have to think about this stuff. like the vDOM stuff. You can just think about like what's the best possible component abstraction or developer experience. So I thought, first of all, I'm going to check something because I think maybe that we need, yes. So we're going to add like a batch thing, because what's going to happen here is that these are like 3 separate assignments. And this is true for any library, even React, that even though if you have an event listener, like you have an on-click and you do multiple state updates, that's going to be batched into one update in the component. But if you do something async, it's not going to batch it, as far as I know. Because, well, the reason is really that by default, changes needs to be synchronous, right? So if you type into an input, it synchronously needs to set the state and re-render, right? So to make that batchable, you have to know that you're gonna batch, kind of. So how do you know that you're gonna batch? You don't really know that. Like we would have to tell it to do that. So what they do is that there's certain parts where they can identify that batching can happen, which is like they control all the callbacks for all the event listeners, like all the on-clicks, on-changes, and everything. So those are like wrapped in a batch. So it collects all the state changes before it like flushes the render. And there are other APIs as well, like a use effect, for example, or whatever. Any callback that's controlled by React or the library can have a batch. But then you do something async, and there's no way to hook into that. So then you don't get that optimization. So what I thought we could do first is to implement a batch. And like Preact also has this, right? Preact batch, like all these batch, right? It's just a common thing. But it's nice to know that you typically don't have to think about it. So how would we do this? So this would be part of observation. Oh, look at me having old stuff. And the cool thing is like the implementation is super, super simple. Like this is the observer. And if I go to create state, this is the proxy. Like this is everything. This is create state. It's deeply nested proxy for reactive updates. It's super simple. And I love that. And then the component is just, I'm going to clean it up a little bit, but it's just Inferno class component that does some stuff. It's like, this is all it is, which is nice. So it's very maintainable. But yes, let's see if we can do the batch thing. And hopefully my brain works. It might not work. We'll see. So this is just... What? What did you make? So... Oh, yeah. Nice. Yeah, it's good to have a backup brain. I was thinking, Adam, I remember I was, this was when, what was his name? Max Stoiber, who built style components. He did this like round of interviews where I and Fabrice, which I worked with for some time on different projects. We were just talking about like our approach to some project. And I thought about the two of us. I think it would be an interesting conversation, like us just talking about all the iterations we've gone through with state management and UI libraries and the panes and the everything. But okay, so the point here is that while batch is running, we shouldn't notify about anything. We kind of queue. Yeah, what are we doing? We're like on notify. Yeah, what are we doing? We are, so we're kind of saying, do not notify. Do not notify. And then we run the batch, run CB, notify. So the way I'm thinking about this is that we're going to register so we're going to have a global flag of like, do not notify. And then when we're trying to notify here, we're going to check that global flag. If we are batching, we are just going to add on notify to a set. So even if it's like trying to notify multiple times, it's just going to add the same on notify to the set. And then we're going to run through that set and notify each of the thingies. Yeah. Yeah. Yeah, it would be so interesting to like just go through history and just all the different projects and discussions and like this, just have this big map of like, you know, that meme with that person with all the threads in the background and the board. Like, oh, it'll be interesting. Okay, let's see. Is batching. Let's just do something false. So we would say is batching equals true, is batching equals false. And then we would have batched notification, batched notifiers will be a new set of this, I think. Yeah, so we're running the callback. Is batching false. We are gonna notifiers. We're gonna do array from. I don't think there's a risk in this case that will, because batch is always, well, just to be sure, batch notifiers. Wait, did I get a message? No. We're gonna clear it, and then we're gonna go through the notifiers, and we're gonna for each them and call them. Or let's call this notify. So I think this is enough. And then what we're gonna do here is I'm gonna create our own thing. If is batching batched notifiers set on notify. Oh, sorry, add on notify. So the point of set is that we don't add notify multiple times. Each observer has their own notify function reference. So it just basically means this observer will only notify once, regardless of how many times it's been told that a state change has happened. Else, we're just gonna on notify. I think this is it. So let's export that and we can test it. Oh, look at me not cleaning up. So let's just export batch and we can test it. Oh, do we actually export anything from Observer? I don't think we do. Observation. Cool. pm build. So let's just try something. Do we have main here? Yeah, to do app. Maybe we can create our own little component. Good question. Yeah, I guess it should. Well, no. So if that happens, what's gonna cause an error is like a re-render, for example, which throws to an error boundary. Like technically it's correct. Like it can cause an error, but I don't think it will cause an error and then like the app will kind of continue. Or like the app will completely break down. So in a state where you would refresh anyways, or you would have like an error boundary thing. So it would be caught by the error boundary. Yeah, like it would be so devastating. Like, what do you call it? Like critical error. We could add it though. Let's see. It's defined in the observation module. Let's see. Something async. So we're gonna return const test. So we're gonna check now if it's gonna render multiple times. Create async. Let's just do like new promise. Resolve. Set timeout. Resolve 1 second or something. Doesn't matter. So if test is pending, return loading. If test error, return error. Return p whoop-de-doo. And then we're gonna see how many times it runs this. Something async, something async. Oh, it only ran once. Is that because, interesting. Why did it only run once? Because we are setting the value and we are changing is pending. Let's check the observer. This should be. Oh, wait a minute. Is it because, wait a minute, create async? No, it should be notified twice. Yeah, let me check. Notify. But it might be that this is an optimization in Inferno that if set state is like called multiple times, Oh, this is weird. Yeah, but there was one for the initial render and then one for... Why is there only one notify? Is object design... This is weird. Let's see. So we are setting properties. What the fuck? Key value, new value. Like, I guess it's a good thing, like that it kind of works out of the box, but I don't understand why. Yeah, it sets to... Well, why is it only notified once? We're saying signal notify. Oh, wait a minute. Oh, I know what it is. It's a bug, yeah. So this is pointing to signal notify, which is... wait a minute. Where's the signal? No, sorry, it's getting the signal here. Oh, no, now I know. It's just because... Oh, okay. Of course. Yeah, okay, interesting. So the reason it works like this is because we're only observing is pending, right? So we're observing one thing. And then we're observing the other stuff. So a way for me to kind of produce this is like test is pending, test error, test value. So now we're observing all these properties, right? So now it should trigger multiple times. Yeah, exactly. Okay, cool. So we see that it notifies twice because we are observing all these things. We're using object design on value and pending, so it notifies twice and blah, blah, blah. But now let's try to put this in a batch. So batch. And then let's see what happens. So it still notifies twice. Let me think about this. Yeah. So it should still notify twice because we are changing two things, but it only rendered once, right? So if we move back just to verify, oops. Oh, sorry. Just to verify. We had a render and a render, right? But not with the batch. So it's seemingly working. Let's put it in there. So we're going to have this on everything async we're doing. And this is something that you could do as well for any async stuff. But typically, you don't really care about this stuff. Ship it, yeah. Let's see. Yeah, and the nice thing is that I'm just gonna fix this, and then we're gonna let's see, async. Where are we assigning? Oh, I think I forgot one place. Because aren't we assigning? Oh yeah, sorry. No, the async is like a one-time thing. So batch. Let's see, batch. That's all, right? Yeah. And then the same for query. Batch. Yeah, what I was gonna say is that, and then I'll just ask Claude to write the tests for me, which is nice. So we just added a new batch utility, which ensures that components doesn't like render multiple times when there are multiple state changes synchronously happening. Could you please create a batch.test.ts file and write some tests that verifies the behavior? Yeah, so this is the thing that's a bit tricky to reason about. So like you can imagine like a more efficient batching mechanism that will kind of just work is that when you do the first state change, you queue the render, right, on a micro task. And that means that any synchronous state change that happens after that is just going to be like applied to that current queue. And that will work anywhere, right? Even if you did something async, you make a state change, it's going to start a micro task, batch up all the synchronous state changes and run all of them in that micro task. That's the most efficient way of doing this. But the reason React and the other libraries can't do that is because they need to have synchronous render. Because what happens is if you do that strategy and you type in an input, for example, you're going to see that the cursor starts jumping. And there's technically an inconsistency between your state and your UI, which there should never be. Or you're going to have a lot of issues. That's going to be hard to identify. So the way they do it manually, like automatic batching, is that there are certain points in the code where they do it for you, which is like on event handlers, like an on-click. All on-clicks are batched. What are other examples? Like use effect. All use effect are batched automatically. And I guess there's other scenarios as well. But I'm very sure that if we do like an experiment here, let's see. I'm not sure how much time I'm gonna get, but let's just roll with this because it's interesting. Like we have thousands and thousands and thousands of sandboxes. That's why this is not working, the dashboard. So if I were to go in here and do I guess, what should we do? Yeah, I guess we can just do a count. Count, set count. So if we have a count here and I have an on click, which is gonna set state count +1. Oh, set count. Okay. Console.log render. Let's turn off strict mode so we don't have that duplicate thing. So, of course, every time I render now, that's fine. But if I were to do set count multiple times, and I guess we'll have to do prev +1. Yes, exactly. Yes, you don't need a run in action thing, right? Because if that action happened to be called from an on click, then it's going to be fine. But if that action was run asynchronously, then it wouldn't actually work. Or at least that's that's my statement. Okay, and then if I do, let me just move my face. So if we do this multiple times, you see there's a single render, right? But what if I now do set timeout. And we do another set count here. And let's stop doing these other ones. So you see it goes to renders, of course. But what happens now if I add more of these? Oh, it's still 2 renders. Does React hook into set timeout? Or maybe if it's, oh, this is interesting. Maybe if it's not from like one of its callbacks. So when they have control of the change, they do this synchronous batching. But if they don't have control of it, maybe they do async batching. That might be. That's pretty cool. I'm gonna see if I can figure that out. So I'm reflecting on how React is doing state change batching. As I understand it, if I do like on an on click and I set state multiple times, it's just going to re-render once. And this is because like React understands event handlers. It's putting a synchronous batching mechanism around that. But to my surprise, if I do a set timeout, which I don't think React does anything with, maybe it overrides it, I don't know. But there I got the same behavior. Like I would expect React not to do synchronous batching there because it's fundamentally async, but it still did synchronous batching in a set timeout. Why is that? How does React do that? Oh. Yeah, automatic batching also applies to async boundaries like fetch, set timer. In the same macro time. But exactly how do they do that? Do they override like fetch and set timeout? Or do they identify? I would imagine like if it's not through an event handler, they just do the other automatic before React only batch updates inside its own event handlers. Updates set time from React batches any updates that happen during the same callback ticking. React now treats that timeout callback as a batching scope. All state updates made with yeah. Yeah, but how exactly does React batch the set timeout? Because this is just happening in the runtime, right? React doesn't know that this state change is coming from a set timeout. Like one way I would see this working is like React actually overriding set timeout and kind of observes all the callbacks in set timeouts and kind of enhances them with this synchronous batching. Or I would imagine that if it's not coming through an event handler, then React will do this like async batching, which means that it kind of asynchronously will do like when the first state change happens, it will queue an async update to collect the rest of the state changes. Does that make sense? Oh, when your React monkey patches the global environment. Okay. So it does do that. That's crazy. That reminds me of Angular and their zones. Have you ever heard of that? Zone.js, which is kind of the same thing. They're completely hijacking the environment to detect where potential state changes could happen, though it just triggered like this dirty check. It was insane. Sure, React doesn't monkey patch set. Instead, every set state just enqueues. Yeah, enqueues an update. React schedules a flush for later. Wire timeout. Okay, but just to be clear, how does React know when to enqueue a state change and when to synchronously apply a batch of state changes? Like, does the event listeners behave differently than async state changes? So what I would imagine is that every single event listener is wrapped by React with like a synchronous batching mechanism. But then if any state change is made outside of that batching mechanism, it's treated as an enqueued set state. You have heard of it? I have. you state that you have heard of it, but end with a question mark. That confuses me, Adam. But yeah, anyways, back to our thing. So, would we be able to? Well, you completely misunderstood me. Oh, a task. With a priority lane on the fiber, schedules a flush later. But what I don't understand is if I make a change to an input and I change the state, and then as I understand, that's put into priority lane. What does that like? Why shouldn't it render immediately to avoid the cursor from jumping? I think that's what I don't understand. Like, what is this priority lane? How does that ensure that renders happen synchronously after multiple state updates? Okay, cool. Oh, yeah, they're getting impatient. Oh, I really wanted to go do create effect and create computed, but yeah, we didn't have time for that. When you call sets a React, never synchron. Oh. High priority lane, async effects, low priority lanes. Yeah, so it's kind of that, right? So user input is high priority, so that happens synchronously. Anything async is a low priority lane, so it's batched. Cool. So one thing I want to try to reason about for us is, let me just answer my partner. Is how could we automate this inside Inferno? Let's ask ChatGPT. So I'm working on a library that's built on top of Inferno.js. And Inferno.js has this user input set state batching natively, but it doesn't have any system for async state changes. So I was kind of hoping that a simple mechanism would be to identify if a state change actually is within one of these event handlers, And if it isn't, then I'm going to create a batching mechanism for it. Do you think that will be possible somehow? I guess what we can do. Yeah, I think what it would mean is that we would have to like interfere with all the props and everything. And I don't think that's a good idea. That's gonna slow things down. Oh. Core batching primitives. How does this work? Your state setter just in queue has pending work. Batch depth. We don't flush now. Outside batching scope. Schedule one flush for this task. I don't understand how this works. Oh, make your event handlers auto-batched. Yeah, exactly. So we have to... Okay, cool. But the thing is that I would want to avoid wrapping all the event handlers because Inferno is handling all the event handlers and already does this synchronous batching. Is there some way, clever way, without hooking into these event handlers that I could know if there's like an async state change happening? I think I'm gonna reflect on this on my own. Like there has to be some way of doing this. Yeah, this is interesting. Let Inferno keep doing its own sync batching for event. You add a tiny async coalescer that fires once per task. Schedule one micro task to flush that work after. Oh, your micro task finds nothing to do and returns. Okay, how the hell does this work? Call this from your state setter right after enqueuing the update. Okay, so this would be in the notifier. Do not try to detect this. Just schedule once per task. Hello there. If you have a hook after own sync flush, you can clear pending. Oh, but I don't have that hook. That's the point. Like I understand if I actually have any way of hooking. That's what I'm wondering. How would I kind of hook into this? Okay, but I need to stop. Okay, I'm not sure what this is about. Cool. But I think this is fine for now. I'm gonna reflect on this batching thing. Like it would be really, really nice to have this. So you don't have to manually batch. We're gonna try really hard to make that work. Even if it has like maybe even if it has some like performance cost, it will be worth it, I think, because having that batch function publicly, like you would never use it. So yeah, and then we're going to implement create effect and create computed. Those are very simple implementations. The interesting thing is like when should those trigger in the component lifecycle? But we can talk about that more when we actually, either I'm going to show you how I did it because I've already done it, or we can do it together on the stream. Okay, cool. Bye for now.